Wasabi, you guys. In this video, I'm just gonna show you guys like very huge important tips for practicing integration B. So let's say like after learning every technique, like what's the next step to do? I do notice that some of you guys have like an integration B in the near future that you're training for. So I'm just gonna give you some very huge important tips for practicing integration B, right? There's a difference, I will say there is a difference between learning how to solve these types of integrals and then performing on stage or performing in an actual integration B. Your mindset kind of changes a little bit, and the reason is because when you're competing in integration B actively, what's going to happen is you're going to be, well, depending on how confident you are, but a lot of the times you're going to be in adrenaline mode, so you're going to have to kind of practice being under peer pressure and being, how to handle yourself in adrenaline while you're trying to solve these integrals as fast as you can. So just kind of be aware that you'll have a different state of mind versus you doing integrals and you doing integrals in an actual integration B competition. Okay, so just want to point that out first, and then after learning how to calm yourself down and getting used to adrenaline, I think the best way to overcome that is you're just gonna have to do a lot of simulations. In fact, I'll put it up right here. I'll put a link in the description where I have a bunch of not mock, but also like integration Bs from the past. This is very outdated. I'm sorry. I will say these are very outdated because I wrote this like years ago, and you're just gonna have to type in integration B PDFs or past problems online. And as you do that, definitely not only just try to solve these integrals, but time yourself. If you time yourself, it scares you more, which is good because that's what you need to practice on. You need to practice being under an adrenaline as you integrate. Okay? So that's that. Next is how to deal with qualifying exams. A lot of qualifying exams, they're like 1 hour. Usually they're 1 hour. But if you're competing against like a very advanced integration B, then usually it's like only like 20 minutes or 40 minutes depending on the difficulty of the integrals. So but for any qualifying exam, whenever you get a qualifying exam like this, or any qualifying exam, the first thing you need to do in a qualifying exam is to look for integrals that you can solve mentally. Well, not exactly mentally. Like, find integrals that you can mentally know exactly what to do, like immediately. Like, for example, like number 3 would be an integral I would solve immediately because I know, oh, this is Wally's trick. So I would do that. And then number 4, I would do number 4 next. And because I notice, oh, this is just u equals tangent of x. Okay, so I'll solve this next, right? So I technically skip these two because they look intimidating, right? And then what else I would choose? Let's see, intimidating. Okay, I see. So there's nothing else. So there's just these two that I can solve immediately right off the back. And then you kind of increase your uncomfortable level. Does that make sense? So let's say, oh, okay, I notice I know how to do Queen's rule here, so I'll just do that. And then next, what else attracts me? Oh, I just realized, oh, I could use beta function on this, so maybe this next. Okay, what else? Oh, let me just simplify some algebra here. Okay, what's next? Oh, maybe there's okay, and then let's say like if you stumble across an integral that you're interested, or that you think that you could do, but then you end up like stuck, retreat. Sometimes you're gonna learn how to retreat just to find easier integrals for the sake of time. Like, okay, let's I'll do this one because this is just a simple graph, or not a graph. Sorry, you can split it up into what, sine to pi, 0 to pi, and pi to 2 pi. And so the integral would just be from 0 to pi of sine of x dx. Right? Oh no, I'm sorry. No, this is the min. I'm thinking about the max. No, the min. Okay, so the integral would actually be pi over pi to 2 pi sine of x. That's what you'd be integrating. Pi to 2 pi sine of x. That's the min. But yeah, so like that. So you kind of increase your uncomfortableness. And then let's say, what's next? Okay, I got these. Okay, oh, I remember this trick. You used times 2 and divide by 2, and use times you use 2 sine of x to split it as sine of x plus sine of x, and then 0 sub cosine of x, right? And then you do that trick, and then after that you do, okay, what else can I do fast? What else can I do comfortably? And then you notice, oh wait, this looks like a reverse product rule, and then you do that. And then let's say, okay, I'm not comfortable with this, I'm not comfortable with this yet, and then you're like, okay, wait, but I'm good at Taylor series, and so you would do this next, right? So even though it's listed in difficulty order, do whichever you feel the most comfortable with, okay? Or choose an integral that you think that you know how to solve, with an idea of, oh, I know exactly what to do and how to solve it. Okay, that is how you should pick your integrals, because a lot of the times it's actually not humanly, well, it's not humanly impossible, but it's rare to get a perfect score on a qualifying exam, especially in advanced integration Bs. Okay, so unless community colleges, you can definitely perfect score easier integration Bs, but usually advanced integration Bs like this, it's not easy to perfectly score it. Okay, even if you go through all the integrals, if you rush it, remember, if you try not to like rush too much, otherwise you're gonna end up missing like a negative, or you missed out on a constant. You'll at least get one integral wrong if you rushed too fast. Okay, so which I'll talk about soon in this video, but for now, again, let's do another example. Right, this is Carnegie Mellon qualifying exam. This is the one that I did before, if you've seen the video, right? Okay, so what's the first thing you see, right? When you flip, or when you start a qualifying exam, the first thing you need to look for is, what can I immediately solve easily and quickly? Alright, so here, the first thing that I would look for is to find integrals that you can solve immediately, or like find integrals that you know exactly what to do like immediately. Like, for example, like, oh, I'll start with this one because it's super easy, right? Start with this one. Okay, next I'll do this one because I know that's a U substitution. Oh, okay, after that I'll do this one. You don't have to do it. You don't have to plan out first. Just dive into the integrals, right? Okay, so I'll solve this next, right? Solve this. It's because I know it's U equals square root of x. And then after that, I would look for other integrals. Oh, I know how to do this one, right? Because that's a U substitution as well if you turn this into cosine over sine of x. After solving this one, I'll look at this and be like, oh, I know this one. This is a gamma function. Or maybe I know what to do because I'll let U cube root of x. And then you use that U sub and then into a gamma. You solve this, okay? And then you go into here. You solve this and you're like, I can't think of any tricks on what to do here immediately, so I'm gonna skip, right? And then here you're like, I don't know if I feel like doing this, so I'm gonna skip, etc. And then there are some times where you actually do end up like, okay, I know how to do indefinite integral on this one, but then you end up in a difficult situation around the process. So sometimes it's okay if you get yourself stuck. Learn to retreat. Okay, like, okay, I'll go back into this. Skip, 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 or oh wait, this is trig substitution. Let me try this first, right? And then you solve this, and then skip, 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 and skip. You're like, okay, so I've done all the easy ones quickly first. Let's do the ones that I can try doing. And so you would try continuing on this, and if not, sometimes if it's better to do an integral that's like bashy versus an integral that you don't know how to do. Okay, so like for example, like let's say like, oh, I'll do this one first rather than this one, because this one I know exactly what to do, integration by parts. I skipped it because it would take forever. But I would rather do that versus an integral that I'm stuck on. Does that make sense? Because your whole goal is to solve as much integrals as possible, okay? Rather than being stuck for like wasting your time not knowing what to do next, right? If you could solve this integral, solve it, okay? Even if it's like, if it takes forever, but you know that you can solve it, do it, okay? Solve those integrals first. And then after that, and then let's say like you have like what? Like 3 minutes left, then you can go ahead and go back to here or solve whichever. But if you couldn't think of any ideas, then you can go ahead and go back to this one, etc. Okay, and then if you have extra time left, then that's where you can go ahead and find, okay, which one that I can solve easier. Oh, this one, because I trig manipulation, and then etc. until you run out of time. All right, so that's how I would go about this qualifying exam. Okay, another example like this. Okay, especially like 10 minutes. Okay, only 10 minutes. Jesus. Okay, what's the first thing you need to look for? Look for integrals that you can that you know exactly what to do immediately, right? Solve this one, power rule. Okay, oh, I know how to solve this one. Okay, so you solve this next. All right, what's next? Oh, I know how to do, oh wait, I know how to do this one because this is, you know, common. Okay, so you would do this one next. You would skip this, and you do this one next because you can solve that one faster than this one, right? And then you notice, oh wait, this one's also, I can do this one fast too. So you would solve this afterwards. After that, then you can go back and solve this. So now you got like 5 integrals done, right? Very quickly. And then after that, you're like, okay, let's see, 3x squared minus 3. Oh, that looks like a u substitution. Okay, so you solve this one. Skip, skip. Oh, this is Queen's rule, whatever. So you solve this next. And then you're like, oh wait, I know how to do loophole logs, so you solve this next. And then after that, you're like, okay, I'm not sure about any of these. And then so you go back and look at the ones that do you know how you can solve fast, but a little more difficult. You kind of amp up your uncomfortableness, right? And then let's, okay, I know how to just do this one. So look for ones that are bashy to you, because you would rather solve an integral versus going for hard integrals like this one where you just, you know, you're not going to be able to solve. So if you know, like for example, like this one, oh, I know how to solve this one, it's just going to take forever, do it. Versus, oh, what is this? Let's find out. But you end up stuck on somewhere, right? So of course, in this case, I would solve for this next, solve for this next, and then solve for this next, right? And then after that, if you have extra time, go ahead and, you know, same process again. Which one can I solve fast, or which one, which integral where I can go like, oh, okay, I know, I have an idea, rather than hesitating, not knowing what to do, right? So let's say like, okay, after all that, I'll go here because this looks like a quotient rule, so let me try it. Then try it, right? Versus, I don't know what to do here, I don't know what to do here. Like, don't attempt, if you don't know what to do, don't attempt it, Okay, so that's how you would go about qualifying exams. Okay, all right. Because remember, you don't get points like they're all every integral is like 1 point. So you have to treat it like if all of these integrals are going to be 1 point each, then do the easiest ones first so that you get the most points. Okay? Because you don't get most points for doing the harder ones. You don't. They're all equally the same points. Okay. Alright, after the qualifying exam, what else do you need to practice on? The most biggest thing in my experience is to practice your accuracy. A lot of us are more oriented towards speed, but here's the thing. When you're under adrenaline, you need to be very, very careful. Okay? Sometimes you can, I wouldn't say hallucinate, but you would think sometimes during a speed solving process, you'll forget something because you go too fast. So when you practice bracket rounds, right? When you practice simulating bracket rounds, right? Find an integration bee that you're going to practice on and simulate. Use a timer, blah blah blah, and then what do you do as you're simulating an integration bee, right? What do? You have a timer limit and you time yourself. So what do you need to focus on at this point? So the reason why I'm using Scranton University is because I want to talk about balancing speed and accuracy. Okay, so it's very crucial. The biggest takeaway here is when you're practicing for bracket rounds and simulating integration bee for yourself, you need to balance accuracy and speed. Okay, be accurate. Do not overpower with speed. Okay, if you go too fast, you become inaccurate. Okay, if you become too accurate, you'll be too slow. So you have to learn how to balance being fast and being accurate. Okay, so speed and accuracy. Balance speed and accuracy. Okay, so how do you train your accuracy? To train your accuracy, you use Scranton University. Scranton University integration bee is the best integration bee past problems to practice with, because the reason is because a lot of these problems, they're easy, right? But that's the whole point of practicing your accuracy. What happens is your brain would be like, okay, these integrals are too easy. So you get the feeling of being impatient. And so when your brain feels impatient, it just wants you to just solve it like done. It just makes you want to solve it in seconds. And so, however, the practicing in this integration bee, you're practicing learning how to slow down a little bit. So you're kind of trying to resist that impatience. Try to pretty much like slow down when you're rushing, because your brain would be like, all right, I just want to rush and get over with. No, learn to kind of slow down. Know where to be cautious, right? For example, you need to be cautious of these like x cubed below. So you're dealing with a negative exponent. So you need to be cautious with constant juggling, and you need to be cautious with negatives. Okay, and putting in the bounds. Oh yeah, by the way, the rules in this integration bee, all answers must be simplified. Okay, so a lot of integration bees you don't need to do this, but in this integration bee you do have to simplify, which is why I prefer this integration bee for practicing accuracy. Okay, so if you want to practice your accuracy, try to solve these integrals fast without getting a wrong answer. Now you might be thinking, oh, that's super easy because all these integrals are like easy. That's what you would think, but knowing myself and most people, these integrals are too easy to the point where your brain would just be very impatient and you would just want to solve an integral fast. I bet you, I know for sure For most people, that at least one integral you're gonna get it. You're gonna get at least one integral wrong because you went too fast. Okay, so if you want to practice your accuracy, this is the best integration bee to practice on. Right? See, these integrals are easy, right? You know, like this one, like you can apply symmetry here, right? But you know, it's just to get you like feeling too comfortable. Does that make sense? This integration bee will make you feel too comfortable until you see things like this, or yeah, like things like this, and then you have to be like, okay, wait, let's be careful. We're going too fast. Don't forget this negative here, right? Or you know, that's easy. This is easy, and then you get to here like, okay, I need to be careful with the 2 and plugging in the bounds, right? So this integration bee is perfect for practicing accuracy. Okay, when you rush, you know your cautiousness, like know where to be cautious at when you're solving integrals. Know where to be cautious, and then if you do end up finding yourself in a cautious position, like, okay, this is dangerous, I need to be careful with the negative, right? Slow down just a little bit, and just check and make sure that what you have during the process, everything is correct. You didn't leave no constants behind, you didn't leave a negative behind, nothing. Okay, so practice your speed and accuracy. Okay, right, and then after you become more comfortable with accuracy, you know, it's pretty much the same process. Practice your speed within accuracy. So in general, you want to balance your speed and accuracy, and if you can do both very good, then you would be the deadliest competitor in any integration bee. Okay, so I think that's the hardest thing to practice, is learning to balance speed and accuracy is the hardest thing to do, in my opinion, because they're not both exactly opposites, but they behave like opposites. If you're too fast, you're not accurate enough, and you'll end up getting a wrong answer, which is you want to avoid at all cost. If you become too accurate, and you're too careful, you can be too slow, and you need to work on how to be cautious in a quick manner. Okay, so this here, Scranton University, I'll put in the link in the description. Practice speed and accuracy, especially for this integration. This helps you practice accuracy, and then applying speed and accuracy, you can use these past integration bees like West Virginia, right? Learn to look, more qualifying exams for you to practice, right? But speed and accuracy, okay? Learn to practice speed and accuracy, okay? What else? Yeah, I think that's about it. Yeah, that's all the hugest, big, important tips on practicing integration bees. So, yeah, I hope that helps. Thank you so much for watching, and I'll see you guys in the next video. See ya.